Okay, so today we're going to work on writing an equation in the form of ax plus b equals c to solve a word problem. Ax plus b equals c is the equation format that we want to follow. All right, let's start with, I find it always nice to start with some sort of a drawing, a picture, some sort of a layout or plan or blueprint that I can follow through. So I read the question. Elsa is saving money to buy a bike. She has $60 and is going to save an additional $5 each week. The bike costs $125. In how many weeks will she have saved? Will she have enough money to buy the bike? All right, so what I want to do, the picture I want to draw here, I think to like a bank balance or some sort of a balance sheet. So over here, I'm going to make a note. This is my balance sheet or my bank balance. My bank balance sheet. All right, and each one of these is going to be a different entry. So I know that if I'm going to write this out, I'm going to say that when she starts, starting balance, they tell me is $60. Okay, cool. So I've got $60 in there. Now, at the end of week 1, it says she's going to save an additional $5 each week. So in week 1, and I'm just going to call it week 1, she is going to add additional $5, which means we're going to add $5. And that will bring my balance now to 65. Okay, week 2 comes and goes, and she does it again. Week 2, she's going to add another $5 deposit. And now, keeping my running bank balance sheet, keeping my running total, 65 and 5 more, now we're at 70. Week 3 comes and goes, and she does it again. Another $5 added, which brings my total to 75. And you're starting to see a pattern now. And so as this pattern continues, we know that the question is asking us to tell us when or in which week, W, they want us to use W for the number of weeks, which week will she add a $5 bill again? And this time her bank balance equals $125. That's the big question, is what week will that happen? Well, as I start to see this pattern emerge through this image or this blueprint that I've drawn, I can see that I'm adding 5 each week. So I know that I'm not taking anything away each week. I know that I'm going to have to add each week. Okay. But this is where it gets a little tricky, and we have to think through how we want to put this together. We know that the end result has to equal 125 right here. So we know that our equation will also equal 125 right there. But the 60 and the 5 per week. The 60 and the 5 per week, we've got to figure out where they go. And the clue here is 5 per week. Because I started with 60, I know that I just have a lump sum plus 60 into my equation, into my bank balance. But if you look, a way that I can shorten this information of all the weeks is I could say, well, $5 times 1 week, $5 times 2 weeks, $5 times 3 weeks, until I got to $5 times some number of weeks we don't know yet. And that's where I ended up at the 125. So now, logically, I've worked through which one of these things, the 60 lump sum or the starting balance or the $5 per week. It's the $5 per week, the word per being our clue, that's what we're going to have to multiply by the number of weeks. So now I can come up here and I can fill in the 5 per week. And I know then that the starting balance of $60 was just a one-time thing, so I don't have to multiply it by anything, and that was plus 60. So our final equation, AX plus B equals C, it's a number and a variable plus another number equals a third number. 5W plus 60 equals 125. I'm in the right format. I'm adding this up together. Now I just have to solve for W. That's the second part of this equation, or this question. Solve the equation in part A to find the number of weeks. We're going to use our order of operations to isolate W to get down to an answer where we just simply say W equals something. All right, so what we're going to do then is we're going to say we have 5W plus 60 equals 125. Is W by itself? It is not. What else is over there with the W? A 5 multiplying and a 6 being added. We definitely want to get rid of the furthest thing from that variable first, and that's that plus 60. I get rid of it with a negative. I have an equal sign, therefore I must do it equally to both sides of, if we look at it that way, of both sides of the equal sign. And what I end up with is 5W still. I didn't change anything there, but I did take plus 60 minus 60, positive, negative, cancel out. I'm left with no number right there, no constant value right there. But I did do this equally to both sides, so I get to still say I'm equal. And 125 minus 60 gives us 65. 5 minus 0 is 5. 12 minus 6 is 6. All right, we're almost there. We're going to start our line of questioning over again. Is W by itself on its side of the equal sign? No. What's over there with it? A times 5. How do I get rid of times 5 or multiply by 5? I divide. I do the inverse operation. I divide by 5. So let's do that. Divide by 5 here. I must still stay equal, which means I must do it equally to both sides. And what I get now is 5 divided by 5 is 1. It simplifies to 1, or 1W. Awesome, that's what I wanted. All right, and now the math on the other side. 65 divided by 5. 5 goes into 6 once with 1 left over. Make a little note here, that's 1 left over. 5 goes into 15 3 times. And that's an even division, so that's the end of my problem. My final answer then for part B, W equals 13. And now if I want to, I can double check my work. I already know that $5 per week, week 13, add another 5, right? We're substituting 13 for where our W is in our equation. That 13 times we deposited $5, we know that that's going to be $65. And then I add the additional 60 that I started at the beginning. 65 plus 60 is 125. Sure enough, I now know that she has enough after 13 weeks to buy that bicycle for $125.